Alright, this could be our next notes in geometry, and we're going to be talking about something called angle of elevation or angle of depression. And this is really going to be based off, we're going to be using some of those trig functions that we learned about, like tan and cosine and sine. And we're going to define a few things, angle of elevation, angle of depression. Then we're going to be able to draw some diagrams and use those things we know about the trig functions to solve for unknowns. So first we have angle of elevation, an angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. So here we have a line of sight, right, between these two people right here. Then we have a horizontal line. And then the angle that's below that line of sight is called the angle of elevation. And then we have another one, angle of depression. This is an angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. So instead of drawing this horizontal line here to the person, we're going to go to the object between the line of sight, and then we're going to draw this horizontal line and line of sight. And then we have this angle that's formed here, and that's called the angle of depression. So the important thing to remember when we're doing these is to draw yourself a diagram, but then you're going to use trig functions to solve, and then don't forget to make a right triangle. So we could, looking at this one right here, like we could make a triangle out of A, B, and C, right? We could just go like this, like that. Then we'd have an angle here, and we could use one of the tan or cosine or sine. We could also form, we knew this angle right here, we could form a triangle A, and we could put maybe this D, and then we have this angle, and we could solve, make this X or whatever, and we could solve and see what it is. So that's kind of what we're going to be doing in this unit. Not a real long unit. So let's look at a couple problems and we'll be done with our notes. So the first one, problem 1, says the crossbar of a goalpost is 10 feet high. If a field goal attempt is made 25 yards from the base of the goalpost that clears the goal by 1 foot, what is the smallest angle of elevation the ball must be kicked? So we're going to kind of draw this. So it says we're 25 yards. Right? See this. This won't be to scale. 25 yards. And then we got a goalpost is 10 feet high, but it also clears it by 1, so we'll just make this 11 feet. Okay. And then the kick itself, the ball, has to go like somewhere in a very straight line in the right spot. Let me fix it. So I'll use a ruler here real quick. So we got that, and he wants to know what angle of elevation, right? So what angle? We'll call it theta. That's going to be an angle of elevation, right? Line of sight. This is the angle below it. Okay. So then we look at what we got. If we had an angle here, this is the opposite. And this is the angle connected, or this is the side connected to the angle. So this is adjacent. And if you remember, we got TOA. So tan theta equals opposite over adjacent. So then we can just go tan of theta is the angle, and that's going to be the opposite, 11 over 25. Not 25 though, right? Because we want to make sure these units are the same. So we have 11 feet. We either have to change this into yards or change this into feet. This is probably easier to change into feet. 3 feet in a yard. So this becomes 75 feet. So it's 75 to 11, not 25. And then we do the math, right? And then we'll do the inverse of tan to tell us what the angle is. Let me grab my calculator. So plug that thing in. We're going to say 11 divided by 75 gives us that. But then we want the angle, so we're going to have to do the inverse tan. So if we hit shift on the key here, then we do tan, and then we do the answer, and we hit equal, should be 8.3 degrees. So the angle is 8.3 degrees. So you have to kick that ball at an angle of 8.3 degrees above the ground. So that's one example of how to use this. There's another one. Okay. This one says the search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need. If an angle of depression to the person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance to the person in need? Okay. So we kind of got a helicopter. We'll just put it point A. Okay. And it says this angle, we're going to have maybe a person over here, right? okay, and the angle of, what is it, depression, so it's going to be 42 degrees here. Right? We just drew a straight line there. It could be 42 degrees there, and then it says the horizontal, and the helicopter is 18 feet above the water, so then we could have like 18 feet, right? It wants to know, what is this x, right? How far away is this person? There's a couple of ways we can do this. One of these, if we know this is a horizontal line, okay, and it's parallel to this, we can use the alternate interior angles, and we would know that this is 42 and this is 42. Another way is we could realize that this is a right triangle, and this would be 90 degrees. So we could say that this is 48 degrees. Okay? If we add them all, this should be equal to 90. And then we have an angle here, and we have, with this 48, we have an opposite, and we have an adjacent, right? So we could do tan theta equals opposite, which is x, over adjacent, which is 18. Okay? And I'll show you the other way too here in a minute. So then we can do the math, and that's just going to be 18, let me write it in here, 18 times the tan of 48 degrees, and that will give us x, the horizontal distance. So let's just do the math here. I'll show you how it's two possible ways. That's the cool thing about math. So we have 18 times the tan 48 degrees. That gives us 19.9. It's about 20 feet. Another way is to use that alternate interior angles. So you could say, since this one's 42, this is a horizontal line, this is a horizontal line, then this one also should be 42 degrees, right? So then we have 42, and we have the adjacent is x, and the opposite is 18. So if we just do this one over here, tan of theta, opposite over adjacent. And if we're doing the alternate interior angles, we could say the opposite is going to be 18, so let's rewrite it, 18 over x. It's the other way. But here we're going to have to move x over here, tan here, so x is going to be equal to 18 divided by the tan of 42 degrees. Well, let's see what that is. So 18 divided by the tan of 42 degrees, 19.9, it's the same answer, so about 20 feet. So you can do it either way. That's what's the cool thing about math. So that's your angle of depression, angle of elevation. Add these to your notebook. Let me know if you have any questions. We'll do a couple more practices in class, and you'll be ready for this unit. See you in class.